Assalamualaikum warahmatullahi taala wabarakatuh. Bismillahirrahmanirrahim. In this part of the topic, we will look at buoyancy. So by definitions, buoyancy is the vertical force on a body immersed in a stationary fluid. So the magnitude of the buoyancy force is equal to the net hydrostatic force in the vertical directions acting on all the surfaces submerged in the liquid. So if you consider a body which is partly immersed in a liquid, as shown in this diagram here, the net hydrostatic force will be acting upward, and that force is the buoyancy force, and the buoyancy force will be balanced by the weight of the body which is acting downward. So let us derive the expressions for the buoyancy force. So let's consider a body partly immersed in fluid as shown here. So let's consider the hydrostatic forces in vertical directions acting on all submerged surfaces that make up this body. So if we consider the force which is acting on this surface here, so the force will be acting downward. So if I call that F dA. So F dA, which is acting downward, will be equal to rho F G, and V above of the surface is V2. Then you can also consider the force which is acting on the surface here. I call that one FBC. So FBC also acting downward will be equal to rho FG V4, where V4 is this volume here. Then I can also consider the hydrostatic force acting on surface DC. So FDC will be acting upward, and it's equal to rho FG, but the volume above this surface DC will be equal to volume 1 plus volume 2 plus volume 4, which is basically the whole of this volume above. So the net, so this implies that net hydrostatic force will be equal to FDC minus F, which is upward, FDA, which is downward, minus FBC, which is downward. So that gives me rho FG V1 plus V2 plus V4, then minus V2 minus V4. So V4 and V4 cancel, V2 and V2 cancel. So I have rho FG V1. And this is actually what we call buoyancy. So what is V1 actually? If you look at V1, V1 is actually this volume. So this is V1 is actually displaced volume, right? So we can say that buoyancy force, which is actually equal to the net hydrostatic force acting upward, F buoyancy is actually equal to rho FG V displaced volume, or because we take rho F multiplied by G multiplied by V displaced, this is also equal to the weight of displaced fluid, weight of the displaced fluid, right? So that means that if we have a body, let's say like that, so this is the weight surface, and this is the displaced volume. So the buoyancy force will be acting upward, and that will be equal to rho G V displaced, okay, and will be acting through a point which is called the COB. COB is equal to center of buoyancy, which is at centroid of displaced volume, right? And of course, since this is balanced by the gravitational force, so there will be gravitational force acting downward, which is equal to mg. So if the density of the body is equal to rho b, so this is also equal to rho b g v body, where v body is the volume of the whole body. So we can write an equation which says that mg is equal to rho fluid g v displaced, or you can also write that rho body g v body must be equal to rho fluid g v displaced. Okay, so the buoyancy force is equal to rho g multiplied by displaced volume, and is equal to the weight of the displaced fluid, and that is balanced by the weight of the body. Okay, so we have shown just now that the buoyancy force, F buoyancy, is equal to weight of the displaced volume. And this is also called Archimedes' principle. And the buoyancy force will act through the centroid of the displaced volume. And the centroid of the displaced volume is also called center of buoyancy. So if we consider a simple example of a floating body, so let's say we have a body like this, and it is actually floating inside a fluid, and let's say this is equal to A, and then this is equal to B, and the part which is underneath the water is equal to C. Okay, and then let's see if I draw 3D. So it looks like this. So the water level is up to there, and this is equal to D, right? So if I draw the free body diagram of the force acting, so we have buoyancy force acting upward, and we have the weight acting downward, right? So the buoyancy force will be equal to rho fluid GV displaced, where V displaced in this case is equal to this volume here, the part which is submerged under water. So that is equal to A times D times C, right? Okay, so I can write F buoyancy is equal to rho F G A D C, right? It's acting upward, and then the weight is actually equal to rho body. So the body has density rho B, G multiplied by the total volume, which is A D B. So we can write an equation which says that buoyancy is equal to W. So we can write rho fluid G ADC must be equal to rho body G ADB.